Hello and welcome to my channel Cosmic Connection. Today's episode is on antimatter. Antimatter is a mysterious and fascinating substance that has captivated the imaginations of scientists and the public alike. In this video, we'll be exploring the discovery of antimatter, its properties, and its potential uses in fields such as medicine and space travel. So without further ado, let's dive into the world of antimatter. 1. The discovery of antimatter. Antimatter was first postulated by Paul Dirac in 1928, when he developed a theory that combined quantum mechanics with special relativity. He predicted the existence of antimatter by showing that his theory required the existence of a particle with the same mass as an electron, but with a positive charge. This particle was eventually discovered and named the positron. In 1932, the positron was discovered by Carl Anderson, who was studying cosmic rays. He found that some of the particles produced during the interactions of cosmic rays with matter had the same mass as electrons, but with a positive charge. This discovery provided the first experimental evidence for the existence of antimatter. Since the discovery of the positron, many other types of antimatter particles have been discovered, including antiprotons, antineutrons, and antiatoms. Antimatter is now known to exist in the universe and is produced naturally in certain types of radioactive decay and in the interactions of cosmic rays with matter. It is also possible to produce antimatter artificially in the laboratory using particle accelerate. 2. The production of antimatter in the laboratory. Antimatter can be produced artificially in the laboratory using particle accelerators. In these facilities, high-energy particles are accelerated to very high speeds and then collided with other particles or with a fixed target. The collisions can produce new particles, including antimatter particles. One way to produce antimatter in the laboratory is through the process of pair production, in which a particle and its corresponding antiparticle are created from the energy of the collision. This process can occur when a high-energy photon collides with an atomic nucleus or when a high-energy particle collides with a heavy nucleus. Another way to produce antimatter is through the decay of unstable particles. Many types of unstable particles, such as mesons, can decay into other particles, including antiparticles. While it is possible to produce small amounts of antimatter in the laboratory, it is currently very expensive and requires a significant amount of energy. As a result, antimatter is not produced on a large scale and is primarily used for research purposes. 3. Antimatter in the universe and its potential role in the early universe. Antimatter is believed to have been produced in the early universe in equal amounts to matter. However, the majority of the antimatter appears to have been destroyed, as there is very little antimatter in the universe today. This matter-antimatter asymmetry is one of the great mysteries in physics and is the subject of much study. There are several theories that have been proposed to explain the matter-antimatter asymmetry, including the theory that matter and antimatter particles behaved differently during the early stages of the universe's expansion. It is also possible that the matter-antimatter asymmetry arose due to differences in the physical processes that occurred during the early universe. There is also evidence to suggest that there may be small amounts of antimatter in the universe. For example, cosmic rays, which are high-energy particles that originate outside the solar system, can produce antimatter when they interact with the Earth's atmosphere. In addition, there is evidence of the existence of an antimatter galaxy, which could contain a significant amount of antimatter. Despite the current lack of antimatter in the universe, it is possible that antimatter could have played an important role in the early universe. For example, antimatter could have been involved in the formation of the first stars and galaxies. However, much more research is needed to fully understand the role of antimatter in the early universe. 4. The properties of antimatter, including its mass and charge. Antimatter is similar to normal matter in many ways, but it has some key differences. The most notable difference is that antimatter particles have opposite charges to their normal matter counterparts. For example, the positron, which is the antimatter counterpart of the electron, has a positive charge. Antimatter particles also have the same mass as normal matter particles. For example, the mass of a positron is the same as the mass of an electron. One of the most interesting properties of antimatter is that when it comes into contact with normal matter, it annihilates and produces a burst of energy. This process, known as matter-antimatter annihilation, occurs because the matter and antimatter particles have opposite charges and therefore strongly attract each other. When they come into contact, they annihilate, releasing a large amount of energy in the form of light and other particles. Antimatter is also affected by gravity in the same way as normal matter. 5. The matter-antimatter asymmetry in the universe. The matter-antimatter asymmetry in the universe is the fact that there is much more matter than antimatter in the universe. This is a mystery that has puzzled scientists for many years, as it is not clear why this should be the case. One theory that has been proposed to explain the matter-antimatter asymmetry is the theory of baryogenesis, which suggests that the matter-antimatter asymmetry arose due to differences in the physical processes that occurred during the early universe. According to this theory, certain processes in the early universe produced more matter than antimatter, leading to the excess of matter that we see today. Another theory that has been proposed is the theory of matter creation, which suggests that matter was created directly from energy in the early universe, while antimatter was not. This theory could explain the matter-antimatter asymmetry if the conditions in the early universe were such that matter was more likely to be produced than antimatter. 6. Antimatter-based propulsion systems for space travel. Antimatter has been proposed as a potential fuel for advanced propulsion systems for space travel. Antimatter has several attractive qualities as a fuel, including its high energy density and the fact that it can produce a large amount of energy when it comes into contact with normal matter. One concept that has been proposed is the antimatter rocket, which would use antimatter as a fuel to power the propulsion system. In this type of system, antimatter would be stored in a container and then brought into contact with a target, such as a block of normal matter. The matter-antimatter annihilation that occurs when the antimatter comes into contact with the matter would release a large amount of energy, which could be used to propel the spacecraft. While antimatter has great potential as a fuel for space propulsion, there are many challenges to using it for this purpose. 7. The medical use of antimatter, including PET scans and cancer treatment. Antimatter has several potential medical applications, including its use in positron emission tomography, PET, scans and in the treatment of cancer. PET scans are a type of medical imaging technique that uses antimatter particles to produce detailed images of the inside of the body. During a PET scan, a small amount of a radioactive substance, called a radiotracer, is injected into the patient's body. The radiotracer contains a small amount of antimatter, usually in the form of positrons. As the radiotracer decays, it produces positrons, which travel a short distance before coming into contact with normal matter. When the positrons come into contact with normal matter, they annihilate, producing a burst of energy in the form of gamma rays. These gamma rays can be detected by sensors, which are used to create a detailed image of the inside of the body. Antimatter has also been proposed as a potential treatment for cancer. In this application, antimatter particles would be used to kill cancer cells while minimizing the damage to healthy cells. One way to do this would be to target the antimatter particles to the cancer cells, using techniques such as antibody-mediated delivery. When the antimatter particles come into contact with the cancer cells, they would annihilate, releasing a burst of energy that would destroy the cells. This approach is still in the early stages of development and more research is needed to determine whether it is feasible and safe. 8. The storage and containment of antimatter. Antimatter is extremely difficult to store and contain due to its reactivity with normal matter. When antimatter comes into contact with normal matter, it annihilates, releasing a large amount of energy in the form of light and other particles. This process makes it challenging to store and transport antimatter, as it must be kept separate from normal matter at all times. One way to store antimatter is to use specialized containers called penning traps, which use a combination of electric and magnetic fields to contain antimatter particles. In a penning trap, the antimatter particles are confined to a small volume and are held in place by the electric and magnetic fields. While this approach is effective for storing small amounts of antimatter, it is not yet possible to store large amounts of antimatter using this method. Another approach that has been proposed for storing antimatter is to use antimatter atoms, which are atoms that are made up of antimatter particles. Antimatter atoms have been successfully produced in the laboratory, and it is possible that they could be used to store larger amounts of antimatter. 9. The potential for antimatter to be used as a weapon. Antimatter has been proposed as a potential weapon due to its ability to release a large amount of energy when it comes into contact with normal matter. If it were possible to produce and deliver large amounts of antimatter to a target, it could potentially be used to cause significant destruction. One concept that has been proposed is the antimatter bomb, which would use antimatter as a fuel to create a powerful explosion. In this type of weapon, antimatter would be brought into contact with normal matter, causing matter-antimatter annihilation and releasing a large amount of energy. The energy released during the annihilation could be used to create an explosion with the potential to cause significant damage. In addition, there are many technical challenges that would need to be overcome in order to design and build a practical antimatter weapon. Thank you for joining us on this journey through the world of antimatter. We hope you learned something new and gained a greater appreciation for this mysterious and fascinating substance. Make sure to like and subscribe. Until next time, goodbye.